thank you very much for agreeing to do this interview this afternoon after 2 days hard work with Karlsruhe software engineers.
It's my pleasure.
So, Marc and me, we prepared some questions, and luckily our questions went quite well together.
Oh, good.
So we have several fields. The first one, it's not very surprising what we are asking. It's about craftsmanship, it's about professionalism, quality metrics, interaction with management, and 2 questions in the end more general, if we still are having an interview.
Okay, fine.
So I think Marc should start.
Okay, the first question we've prepared is, how would you define software craftsmanship? What's it mean for you?
How do I define software craftsmanship? So I'm in the midst of this dilemma, because I want to bring the notion of software professionalism and software craftsmanship together. And craftsmanship seems to have something to do with how well you perform your craft. And professionalism is more the relationship to others that you have. So there's this mix between the two. Software craftsmanship is really all about taking this profession that we have, this job that we have, and turning it into a real profession, turning it into something that professionals do. It's about defining the sets of disciplines and the minimum standard of behavior for someone who claims to be a professional software developer. And that includes how well they perform their programming, how well their code looks, and also how well they do their job in terms of estimating and communicating to managers and communicating to other software developers. Imagine that it's 300 years ago, and we were talking about the medical profession. And there would be practitioners all around who would be willing to pull out your tooth or willing to cure your aches and pains with whatever. And a few people looked around and said, no, there's got to be some way to raise the level here. That's what software craftsmanship means to me. It's a way to raise the level, to create a group of software developers that employers and governments can trust.
So to you, it means more than just writing clean code?
It's part of writing clean code, but it's much more than that. Because our civilization is heavily dependent on software. If you look around the room here, there is software running within just about every square foot of this room. There's software in this microphone. There's software in that remote control. That clock there is probably run by software. The camera that's filming this is run by software. There is software in everything. How many times per day do you put your life in the hands of some 22-year-old programmer who wrote some code at 3 in the morning? And the answer to that is too often. And at some point in the near future, there's going to be an accident, and thousands of people will be killed because of some piece of software written by somebody who got a little too careless. I would like to not prevent that from happening. I don't know that it's possible to prevent it, but when it happens, and when the governments of the world rise up and say, my God, what's happened and how has that happened, I would like the software profession to be there saying, but we did our job well. This is not because we've been sloppy and messy. This is not because we are unprofessional. We have been doing our job well. That's what I would like to have happen. Today, I couldn't say that.
Okay, so
just to start this out on a pleasant note. Sorry if I overloaded your microphone there.
Do you think there's one thing a software craftsman should do, or someone who wants to become a software craftsman? What's the most important thing?
Well, the most important thing to do is first of all, make sure you're in the right job. There's a lot of people who are in software right now that just shouldn't be. because they consider it to be a job and not a profession. You know, when you go to a doctor, do you want that doctor to love what he does? Or do you want him to think of it as a job? Just do it. It pays the bills. You want a doctor to be in love with his profession. You want a lawyer, if you're, your freedom is going to depend on a lawyer. You want that lawyer to be in love with his profession. If you're going to commit a massive project to software developers, you want those software developers to be in love with their profession. So the first thing is to decide whether you're in love with your profession. If you're not, find one that you are in love with and don't be in this one. Second thing to do is to learn like crazy. Read as much as you can. We now have 50 years of experience in software. That's not a lot. Most professions have centuries at this point. We have 5 decades. But within those 5 decades, there have been notable professionals who have written about their job. People like Tom DeMarco and Ed Jordan and Edsger Dijkstra and a whole ream of these people. And you can read their works and understand what they thought professionalism is. Learn the languages of the past. If you're a Java programmer, my God, learn some other language, because Java is not the end of this story, and it's not the beginning of the story. It's just a little tiny brief segment, and it's going to move on to something else relatively soon. Find other languages, learn those other languages. Communicate with other programmers. That's very difficult for programmers to do. Right? Programmers, we got into this business because we like people. But it's important for us to communicate with others, to practice together, to become a community of practice and a community of professionals.
When I came here yesterday morning, I discovered you made a list of and asking people how long they were coding in their life.
Yes.
So you're talking about falling in love with your job.
Yes.
And I've seen very many people here who were in love more than 10 years. So what the interesting question was for me, why does this need to become more perfect or better in love or more addicted to its own work is rising so late? Why don't younger people try to get better, coding people?
Well, I think there's always been a subgroup of programmers who were in love with it. It was a passion that struck them early in life, and they knew what they wanted to do by the time they were 16. As I polled the group out here, most of the group started writing code well before they went to college. Many of them were pre-teenagers as they started writing code. They touched one of their father's computers, or they found some interesting device and they realized they could program it, and they fell in love with it. There's a whole group of programmers who got into the profession because it was the smart thing to do. It was the profession of the future, and they never had the passion for it. Some of them, I think, can develop that passion. I think that's all right. But there are many who view it as 4 years and then I'm off into management. And that's not helpful to the profession. I don't think we want to encourage that kind of participant. I think the people we need in our industry are the ones who find that passion early and nurture the passion and want to stay programmers. I don't know how things are in Germany. In the United States, we face a lot of pressure to move into management. If you're a software developer for 3 or 4 years, well, it's time for you to leverage up and start running a group or something like that. I find that very unfortunate. We do need good managers. That's fine. But software developers typically don't have that skill, don't want that skill. Right? And they feel the pressure to move in that direction. Many of them do, and many of them fail. And then maybe they will pursue some career, often marketing or sales or something, and lose their original passion for what they were doing. I've certainly faced that several times. And I have been a programmer, then I've run a group, and then I went back to being a programmer, and then I ran a division, and then I went back to being a programmer, and then I ran a company. And then I gave that up and I'm a programmer. And now I'm a programmer who does a lot of speaking and talking. And I'm very happy with that. So some people don't have that love, that was the question you asked me, because they got into it for the wrong reasons. Some of them develop the love because they find out it's very good to be a programmer, it's fun. And some of them lose the love. And they lose it because they find themselves in an environment that crushes that love out of them. It's an environment where they are driven by deadlines and driven by pressure, and they have to work overtime. And after a while, they ask themselves, why did I get into this horrible situation? And they go and become a chicken farmer.
Well, do you think such professionalism is essential? Do you think there can be software of high quality, for example, without such an attitude?
Yes, there can be software of high quality without that attitude. That's perfectly possible. But is it essential? It's absolutely essential. Because although there can be software of high quality, most of the software out there is not. Most of the software out there is, in fact, of dismal quality. Right? As I wander the way through the industry and I look at the code that's out there, the vast majority of it is terrible. And that's very unfortunate. Our customers do not have the capability of looking under the hood of the car, opening up the hood of the car, looking at the engine and seeing that it's a good engine. They can't do that. They have to trust us. And we tell them, the code's working, it's fine, don't worry about it. If our customers ever developed the skill to look under the hood, they'd be terrified in what they saw. And they'd realize they spent a lot of money for very rickety, very fragile software that has a great propensity to harm them. That needs to change. So that's where professionalism comes in. Who is going to police the software developers? And I want it to be the software developers who police the software developers. Just like the doctors police the doctors and the lawyers police the lawyers. It should be the software developers who set their own standards and then keep to them. And right now we're not doing that.
So often what you hear from managers is that clean code is too expensive, or you cannot afford writing tests that cover like all the code. That's just too expensive. You cannot do that. How would you respond to that?
Hey, if I don't have to make the code work, I can make it as cheap as you'd like and deliver it on any schedule you want. As long as it doesn't have to work. Right? Actually, it's not managers saying that. Oh, you might find some low-level manager saying stuff like that. But you talk to the CEO of a company. You ask that CEO, you want your software to be high quality? And he's going to say, well, I thought it already was. Of course I want it to be high quality. I'm betting my business on it. I'm running my business. Imagine a company who's running their payroll or their invoicing or something critical to the business on software that their software developers are producing. And ask the CFO if he wants high quality software there that doesn't make any mistakes. You're damn right I do. Right? So the little manager off in the corner who's worried about the schedule is going to say something silly about like, oh, well, we don't really have time to write tests. Of course you've got time to write tests. You don't have time not to write tests. How much debugging do you want to do? How much chasing down horrible invoices do you want to do? Or correcting corrupted databases do you want to do? Of course you have time to write tests. And if you were to talk upwards, up to the managers above him, you mean they're not writing tests? You mean there aren't any tests? What kind of professionals are these? The people who complain most about not having time are the programmers themselves. And they do that because they're afraid that their managers will say, you don't have time to write tests. They're afraid that their managers will say, you don't have time to clean code. They have cause to be afraid because they've been put under a lot of pressure to deliver. And they've been put under a lot of pressure to deliver because they haven't delivered. They have made estimates and they've missed them. There's a huge amount of distrust right now between the software management and companies and the developers themselves. And that is directly because of a lack of professionalism. It's because of software developers bowing to schedules that they should have said, no, I can't meet that schedule. We're going to have to come up with another one. It's because managers would manipulate, low-level managers would manipulate developers into committing to things they knew they should not commit to. And the developers were too unprofessional to stand up and say, no, we're not going to do that. And they wind up under pressure, they wind up failing, and then this distrust grows, and it's a terrible thing. Developers need to learn that one of the marks of professionalism is that they be able to say no. A professional says no. A professional is hired for the purpose of saying no, and then also offering what else they should do. Developers need to learn how to say no. Developers need to learn how to define their boundaries, learn how to make their commitments, learn when not to make commitments, so that the business can begin to trust them.
That covers my next question. Because I've read the very interesting dialogues in your new book between Mike and Peter.
Oh, yes.
About estimation and commitment, which is exactly what you were describing there. And reading that, I can't understand. I'm not a developer. I can't understand why I should promise something where I don't know what I'm promising. I just promise things where I'm sure that I can deliver. So you said an interesting word. You said distrust. Why the distrust is such an important obstacle in this field of work?
Well, distrust is always an obstacle in any kind of work. If you don't trust your doctor, you're going to get another doctor. And if you don't trust your lawyer, you're going to get another lawyer. Unfortunately, the business is locked into a bunch of developers that generally the business doesn't trust. And so they try to find ways to manipulate the developers in spite of this distrust. So they will set deadlines and put massive amounts of pressure on developers to meet those deadlines because they believe that's the only way they can get anything done. They will attempt to manipulate or put pressure on developers to commit to things because they believe that's the only way they can motivate the developers to actually get things done when they say they'll get done. And not all companies do this, and maybe not even most companies do it all the time. But most developers have been through that experience. When there is trust, something very different happens. Management goes to development and says, we need this by next November. Development says, that's not going to happen. Management says, well, what else can you do? Developers lay out what they believe they can do. Management chooses amongst those options, and everybody goes away knowing that that's the best they can do. In the midst of that, there might be some heated discussion. Managers might say, you don't understand. There's a customer out here that we're going to lose if we don't deliver. And the developers have to have the courage to say, I do understand you're going to lose that customer because we cannot deliver this. And then the business goes, oh. And they trust the developers who said that, and they say, all right, we're going to have to work on that customer. Instead of trying to push the developers to do the impossible and then losing the customer anyway out of failed expectations.
We jumped over the quality and metrics. Yeah, it's true. Totally different topic.
Yes.
Around and around and up and down.
I jumped a little, yes.
It's okay.
So, the current issue of the magazine we are doing this interview for is about quality in general. And
its title is Arrow.
Yeah, when it comes to quality, many people turn to metrics to measure the quality. Do you think that's worthwhile doing? Does that help?
There are some reasonable metrics to measure the quality of software. the internal quality of software. There's metrics like cyclomatic complexity and lines per method and so on, and they're useful. These are not management metrics. I don't want managers looking at reports about cyclomatic complexity. That's nonsense. I don't want managers looking at reports about code coverage and test coverage. That's also nonsense. These are metrics that we as developers should use to police ourselves. Where does quality really come from? Quality comes from developers writing good software, using good requirements, writing good tests, making sure those tests pass, and developing a discipline to never rush in order to meet a deadline. You rush to meet a deadline, you're going to go slower, you're going to create lots of bugs, it's going to make a mess, so you develop a discipline, never rush. Lots of companies will create departments, quality assurance departments, QA departments. They have done this. Excuse me. They have done this out of defense, as a defensive mechanism, because the development community has not done their job. Developers produce products that have bugs, and then the business decides, oh, well, we need a whole new department to make sure that developers don't produce bugs. They create a QA group. QA groups actually do have a good function, but we use them the wrong way. We take the QA group and we put it at the end of the project. We say, okay, QA people, now you're going to test this code that the developers wrote. Why didn't the developers test that code? When the developers wrote it, they're the ones who ought to test it. Why do we have to hire another group of people to test the code that the developers wrote? And then what are these QA people doing? Are they manually testing this software? Are they actually touching keyboards and looking at screens and making sure the software behaves correctly? How many times do they have to do that every year? Do they have to repeat the same set of tests every 6 weeks to make sure that the software is still working the way it was supposed to? What a job that would be. What a horrific job. Every 6 weeks I'm going to do the same thing. I'm going to log into the system the same way. I'm going to test it the same way. And my mind will turn into homogeneous honey because I can't see it anymore. That's the wrong thing to do with people. Imagine a group of developers who deliver late. That would ever happen. And the date can't change. So what group has to make up the difference? The QA group has to make up the difference. They're the ones who have to now execute their tests much faster than they would have before. And now they're put in a position of having to choose which tests to run and which tests not to run, which ones are too expensive. And they're under pressure. And it's a high-stress, tedious job. And so it's error-prone. Just exactly the wrong thing you want at the back end of the process. What we want to do there is automate all these tests. Most of these tests should be automated. And they should be run by the developers. Developers should write the code. They should run the tests. If the tests pass, then QA is already signed off. I want QA writing those tests. I want QA writing the acceptance tests that the developers have to pass. I want the developers executing those tests automatically, so they can push a button and know that they're done with what they were supposed to do.
So do you think there's a place for manual testing?
Of course, but not scripted. Manual testing is very important. I want someone with their eyes on the screen and their fingers on the keyboard, but I want their brain engaged. I want them thinking about interesting and clever ways to break the system. I want them going to bed at night, strategizing how they're going to destroy the system. What interesting sequence of inputs will confound and break it. I want the QA people to be applying massive amounts of creative energy to find out ways to break the system that the software developers never thought of. That's where QA people have real value on the back end. And their value on the front end is that they're writing the acceptance tests that specify the quality that needs to be put into the system. This, of course, is what QA people have been telling us for decades. Just now beginning to realize it.
So in your book you write that QA should find nothing, right?
Yes.
So you think when they all try to find a way to break the system, they won't find anything?
Yeah, exactly. That's exactly what I want. I want a bunch of guys dreaming every night about ways to break the system and failing to break the system. You know, they can't find any way to do it. That's a perfect situation. And of course that won't happen. What will happen is the QA will find things. And then I want the developers going, how the heck did that happen? And they would change their processes and their disciplines to make sure that can't happen. And then the QA people have to get even more creative. I want an escalation in creativity over this issue. The developers and the QA folks should be in a kind of competition. Development is absolutely certain they're not going to find a bug. QA is determined to find a bug. That's a very profitable way of working.
So it's more like an attitude.
Of course it's an attitude, yeah.
Okay.
We can go to the general part. But it was your question.
Okay. So you think there's what's the biggest challenge that the software industry is facing today or will face in the next couple of years?
Well, there's a couple. The biggest challenge is this issue of professionalism. We have a huge deficit of professionalism, and that needs to be resolved. And we're in a race over that, because at some point, as I said earlier, there will be an event, an accident of some kind, and the governments of the world will get involved, and then they will decide they have to police, and that will be bad. That's happened to other industries in the past, and it would be very nice if our industry had achieved a level of professionalism where we could hold back the laws and the imposition of governments upon us. So that's the first challenge, and it's a big one. The second challenge is a technical one. And it's no less daunting. It's a very interesting challenge. Our computers have been enjoying an incredible increase in power and speed over the last 40 years. Moore's law has said that the processor speed will double every 18 months, and the density of transistors on chips will double every 18 months. We have seen that happen for 4 decades, since 1970, to the extent where this machine is probably 22 orders of magnitude more powerful than the little computer I started working on when I was 18 years old, PDP-8. But around 2000, 2001, 2002, Moore's law began to fail. The speed of computers stopped doubling. They've been stuck now at about 2.5 gigahertz for 5 or 6 years. And to compensate for that, the hardware developers have begun to change the game. They've added multiple cores. So this laptop here that I'm working on has 4 cores inside it. 4 processors, each running at about 2.5 gigahertz, which you'd think would mean that there's 10 gigahertz in here. But no, that's not the way it works, because the software is not written to use multiple cores. So we wind up with the inability to spread the execution of the software across those cores. Come back in a year and I'll have an 8-core laptop. Come back a year later, I will have a 16-core laptop. Year or two after that, I'll have a 32-core laptop. When does that stop? Well, it's going to stop at some point, but probably not before we get to 32, 64, maybe 128 cores. The systems that are out there are all going to be heavily multi-cored, and our software doesn't deal with that. And our skills are not up to that. Most software developers think that they live in a single machine with a single thread, and every once in a while they create another thread and whatever. They have no idea of the complexity of making a system that can run in 128 cores. So the technical challenge is for the software community to learn the much more mathematical, much more scientific, much more technical skill of building software that can run in a heavily multiprocessor environment. That will become essential. There are lots of strategies out there to prevent software developers from having to learn that. There's a bunch of people who think they can create a framework that will make it so that programmers can program as usual and the framework will take care of everything. No, they can't. Lots of people for years and years have tried to make it so that programmers can be stupid. It is never a good idea for programmers to be stupid. Languages were written so that programmers could be stupid. COBOL, a language written for people who want to write in English instead of code. Okay, didn't work out all that well. The idea that object-oriented design was too complicated for mere mortals. We don't want normal programmers to do objects. It's just too hard. Completely failed. Everybody's doing objects. Functional programming is going to be the next hurdle. Everybody's going to have to learn how to be a functional programmer. They're going to have to learn the mathematical and technical skills that will make them a functional programmer so that they can live in the multi-core world. That'll be a very interesting time.
Yeah, sounds like it.
Yes.
Your new book just started, The Clean Coder.
Yes.
The first one is, or the one before was The Clean Code.
Clean code, yes.
The next one.
Clean coder, yes.
The Clean Codest will be the third one.
Oh.
How will we continue?
The next book is called Clean Architecture and Design. And I'm in the midst of writing that now. And it talks about the next level up from clean code. Once you know how to write clean functions, clean algorithms, once you understand that, how do you create clean architectures? And we have a huge problem with that right now. We've got massive amounts of systems being written, and the people who are writing them have no idea how to structure the architecture. They have been subverted by the marketing literature out there. So there's this massive amounts of stuff being done with service-oriented architecture, as though it were an architecture. Service-oriented architecture is going to solve the architecture problems of the world. No, it's not. It's an interesting technique, useful in some cases, but it's not the massive, big architecture that's going to solve the world's problems. Lots of people did three-tiered architecture for a while. Tremendous amount of architectural experimentation going on. The problem with that is that a lot of the architectural science was done 30 years ago, 20 years ago. We know how to build these systems. We've got books that tell us how to write these systems, and yet most of the developers out there just don't know that. They don't know what a system architecture ought to look like. They don't know what the rules of a system architecture are. So this book attempts to address that. And it tries to address it in the same way that Clean Code and Clean Coder did it, by being as prescriptive as possible. These books take a different tack. Most books lay out facts and issues and allow developers to make up their own minds. But these books that I've been writing become very prescriptive. They say, do this. Now, I make it clear that it's my opinion, but I'm also telling people, okay, this is my opinion. You should do this. That puts a different slant on things.
How does that relate to emergent architecture and things like that? The idea of extreme programming, that the architecture will evolve or eventually...
So that's an interesting one. And architecture emerges, design emerges, but not without human brains. It is not the design that emerges out of nothing. It is the design that emerges out of the activity of a programmer evolving their program forward, and while doing so, applying design principles that they have learned. All the design principles from the last 40 years still apply. They're all still valid. Right? It's just that the order in which we do them has changed. Instead of doing them all up front and planning some massive software thing, we apply those principles sideways. We write a little code. We write some tests and then some code, and we look at the structure and there's a principle violated here. Let's shift it a little bit, and we refactor it for that principle. And then we write a little more code and a little more tests, then we refactor for that principle. And we begin to build a system that starts to look like it needs an architecture. And then we start to build out the pieces of that architecture. We evolve it. It emerges, but not without human thought, not without all the principles that have always existed. People get into this religious war about, this agile stuff is about not planning. No, it's not. It's about planning all the time. People say, well, the design emerges, you're not supposed to use your brain. I had a guy last night who said, I've been told that I'm not supposed to use my brain. I'm not supposed to think. Well, it's absurd. Of course you're supposed to think. It's just that you think at a different time and in a slightly different way.
Sounds very interesting. You next year in Karlsruhe for another clean architecture and design course?
No, it could be.
Any more questions?
No, that's right.
Anything you would like to add that we didn't add?
Oh, goodness, what haven't we said? Who reads this magazine? Who reads this magazine?
Software engineers from the region, from professors.
Software engineers for the region. Okay, so here is a message for all the software engineers in the region, Karlsruhe region or the region around here. There is a discipline you need to learn. That discipline is called test-driven development. It has been controversial for a number of years, but the jury is in. This is something you need to do. Something you need to learn, and something you need to practice. We are at a point now where in the industry, probably 10% of developers are beginning to practice test-driven development. It will become the definition of professional behavior, one of the disciplines that helps define professional behavior over the next 10 years. Learn it, understand it. You are going to need it. It will be probably the most important thing for you to learn in the next year.